Hello guys, welcome back to the channel. Let's solve another problem from LeetCode. It's a problem 49, group anagrams. We have already solved valid anagram problem in the series, and I recommend you go and check out that problem too. That will help to understand this problem. So in the previous problem in the valid anagram, we all need to check if two strings are valid anagrams of each other. In this problem, we are being asked if we are given this the strings, right? And uh, we need to group them into separate groups, right? Let's say we are given this array strings and we need to group the anagrams, and we can return the answer in order. Right? To just simply remind what's anagram. Anagram is a word or phrase formed by rearranging the letters of different word or phrase using all our original letters exactly once. Let's say in this example, for the the first element, eat, right? Eat, how many characters are there, right? Basically, E is appearing once, A is appearing once, and T is appearing once, right? And the next element is T, right? For T is T is appearing once, E is appearing once, and E is appearing once. So basically, we can see the character count. E is once, A is once, right? T is once. So basically, these two elements, they are the anagrams, right? And we check the other one, Tn. So T is 1, A is 1, N is 1, right? The character count of Tn and Ta, they are not matching, so basically they are not anagram. And the next one, right? E is appearing once, T is up once, E is appearing once. So basically, what we are being asked, group this E, T, and 8 into one group, and Tn and 8A, we can group one goes into separate group, right? So that's a problem statement. So let's see how we can solve this problem. So I will try to explain the three different approaches. One is the brute force approach, and the second one is suboptimal approach with the sorting. And the we'll just look at with the hash map. That will be the optimal solution. So let's solve this, right? Initially, in the brute force approach, what we do, we initially create the array with the length of the input array, right? Input array of strings, right? Basically, we say all of them, they are F, which means like they are visited. F is for false. They are not visited. So then what we do, we check the first element, and we initialize the empty list. We check the first element if it is already visited. If it's not visited, then we add that to the list, right? Then we mark this one as visited as true. And we go to, for this element, and we check for each the subsequent elements, right, until the end of the array. So we check Tn. How we check? So how we compare? We basically do the character count, right? So the first element, E is 1, A is 1, T is appearing once, right? So for the first element, we go, after we process, we just mark this as true. Then we check every subsequent element after that, right? Then we check the character count with this one, Ta. So E is appearing once, A and T, they are all ones, right? Then we can see they are matching. After we see the match, then we mark this one as true. Then we add this T in the list, right? Then the next one we check. After we check, the character count is T is 1, E is 1, N is 1, right? They are not matching, so we will not add to the list. and we go to the next one, then character count matches, so we add this to the list, right? Then we mark this as true visited, so that this will improve the efficiency, right, a little bit. And the last element we check, it will not, right? Basically this is done. Then we go start processing from the next element, right? Next element, every subsequent element we need to check. So for T, we check if it's already visited, then we will skip this, right? Then we go to the next element. For the Tn, we check every subsequent element, basically, and we checked if this is not visited. This is already visited, so we skip this. Then we go to the next one, right? Tn. So basically, this is Tn. Then we add NAT. Then that's it, right? Then we need to mark this one and this one as true because we have visited, we process them, right? And the last element is not processed, and we basically process that and add to the new list, right? Bad. And at the very end, we just, add them all to the list to return. So basically for each element, we are processing every subsequent element. With the visited list, it's helping to improve efficiency, but basically for each element, we are processing every subsequent element in the list until the end of the array. So basically the time complexity is going to be order of n square, right? So, and also there is a sorting is happening there, because not sorting, and the counting, right? Counting the character. So let's see the code for this approach. This is the code for this approach. So initially, as I said, we initialize the results array. Then we initialize the visited array as all false. Then we start iterating every element, right? If it's already in visited, we skip it, we continue. Then if it's not visited, then we add to the string, and we mark that as a visited. Then this is I. Then we process every subsequent element in the array. So that's why j is I plus 1. If not visited, if the counters they are matching, counter of characters they are matching, we add that to the group and we mark them as a visited. At the very end, we just compile all of the anagram groups to the result and return the result, right? This is basically, if you want to submit this solution in the lead code, that will take for the large arrays, that will basically time limit exceeded, TLA, it will return, right? Basically, this is a brute force approach, and this will work fine for smaller size arrays, right? How we can improve this approach, right? Let's say the second approach is through sorting, right? Through sorting. What do? Sorting and the hashing, right? Basically. Sorting and hashing, this will definitely improve, and this will be passing this submission. So what we do, we start processing the first element, right? And then we sort this, right? After we sort this, alphabetical sort, EET, right? This will be sorting. Then we will just start collecting. The sorted element will be the key, and the element itself, EAT, it will be the value, right? Then we go to the next one. Is the sorted element, are they equal, right? The sorted element, it will be equal to EAT, right? That's the sorted. So if we sorted T, it will be like alphabetical sort, it will be EET, right? Then we also add this one to the list, right? Then we go to the next one. No, it doesn't work. And because this goes to if we just sort this one, it will be A and T, right? It will go to different key and different value, right? Basically, this will go to 10. And the next one, if we sort this one, this will go to the opposite, right? AET. And we need to add this one to the first list, right? ET. And this is done. And the next one, NAT, if we sort NAT, it will be INT, right? INT, it will go to the second element in the dictionary, and the last element, it will be ABT, and it is by itself, right? BET, right? So then at the very end, what we do, we can just do the list. I think this is we can do list, and at the very end, and this will be all of these sorted elements. They will be the keys, right? And this will be the values. And at the very end, we need to return the list of the values, right? So this will definitely improve the efficiency. And let's see the code. So initially we initialize the dictionary to store the groups. Then we iterate only once here, but it's not going to be in square, right? This will be n, because the n is basically the number of elements in the array. Then since we are sorting by the size of the word, right? Right now this is 3. It may be the largest can be like any, like in a size, let's say k, right? If it's k, n, basically k log k, right? This will be the time complexity. And this will definitely pass the test. And here we sort and we join, and this is a sorted word, sorted element. Then it will serve as a key, and we add the word as a value, right? We collect all of the words as a value, and then we will return all the values as a list, and this will be passing the submission, and it will be suboptimal solution, and it's for medium-sized arrays. This is a really good approach, right? So the most optimal approach, it will be the frequency counting. Let's say frequency counting for each element, right? Let's say for let me just get AT, right? AT initially this is lowercase English letters in the constraints. So lowercase English letters, how many of them are there? There are 26 of them, right? If you can see here, 26 A, right? A in a decimal, this is a character in decimal Unicode, is basically 97, right? And B is 98, and this is basically from 97 up to 122. And we need to, how we can convert this to the zero-based index, right? How we do here, we are going to initialize the count, right? Count array, and we just initialize them by 0 by 26, right? Because because English, lowercase English letters, there are 26 of them, and to count these characters, we basically convert this Unicode to zero-based index. How we do this? This is 97. We basically subtract this element, right, from the letter A, right? Let's say A minus A is going to be 0, and B minus A, B is 98 and A is 97, it will be 2, right? Basically, it will range from 0 to 25, right? And what we do, let's say for E, right? E here, which element? 4, right? 4. And A is 1, right? The 0, right? A is 0. Then T, it will be here, right? 19. What we do, we basically for this array, we put this one 1, and this is 1, and this will be 1, and all other elements, they will be filled with 0 because there is no character for in this element, right? If because there is no B, there is no A, right? There is no D, right? There is only A, E, and T, right? Their count will be 1 and everything will be 0, right? So then to really use the hashing, we need to convert this into tuple, right? Tuple is hashable, and the list, initially we initialize this as a list, and what we do, let's say then we can use the count tuple as a key, and the element itself is a value, right? It's similar to the sorting. Instead of sorting, we are counting the number of characters in the element, right? So what we do here for EAT, it will be the same, right? A is 1, and E is 1, and T is 1. Everything else, yeah, this is 0, this is 0, and this is 1, right? Basically, this will be the count, will be the key, and this elements will be the value, right? The count we convert to the tuple, right? Then we save them inside EIT, then EAT and T, right? This will be as a key. At the very end, we just simply return the values, right? A list of values. So let's see. Initially, we initialize this as a dictionary. Then we iterate each word, each element in the string. And for each element, we initialize the count array of size 26 due to this, the lowercase English letters. And we for this we for inside S, right? Each character. This is a C for an S. Each character we try to compute its count, right? It's this is E, right? If this is E, what's the character? If this is 1, then we just increment that count for each element of the string S. Then after we collect all of the count string, we update them, like increment the count based on the character. Then we convert that count list, right, to the tuple. Then we use that tuple as a key to the dictionary, and we add that S string itself as the value, right? We collect all of them, then we return. So basically, this is the most optimal solution. And the time complexity, E is going to be n times k, right? N times k, because here we are looping once, and here we are looping once for each character, right? For each character of the element, and counting their appearance, right? Occurrence. So basically, for the brute force approach is time complexity n squared k, and sorting plus hashing. In the second suboptimal solution is going to be n times k log k. K is the length of the longest element in the strings, right? And the last, the most optimal solution is going to be hashing by frequency counting, and initializing this count with the size of 26 due to the lowercase English letters. Then space complexity nk, and O of n, right? So basically, right now for this problem, we discussed 3 solutions. The first one is basically the brute force approach. That's n square, and that will definitely fail the submission. It will not pass. And for the second one, we are basically sorting and hashing. And by sorting, by sorted word, we are using as a key, and the word itself. Before sorting, we are collecting them as a value, right? Then the last element, the last solution, we are using this frequency counting. We are counting the number of characters in each word in the string, and the collecting, right, forming that count string with the size of 26, and we are converting that into tuple so that we can use that tuple as a key. Then we are collecting them into the dictionary, and we are returning the values of the dictionary. Right? I hope this is clear. And if you have any questions, please share in the comments, and I will try to answer. Okay, thank you. See you in the next video. Bye.